Hello, this is Dr. Mears. Today we are going to be learning about interpreting a scatterplot, correlation, and the equation of the regression line. So let's get to it. The data shows the price of a certain manufacturer's flat panel LCD televisions in the area of the screen. So here we have the table screen area in square inches and the price in dollars. Here we have the scatter plot. And it does say for number 1, plot the points on a scatter diagram. I actually gave that to you because I'm going to run through the directions to make this on the calculator. I want you to notice the area is the X value and the price is the Y value. And the reason why the area is the X, and I'm just going to put X, is because you input area and you get out how much your television is going to cost. So your input's X and your output is Y. For our knowing right now, our L1 is going to always be the X, which is the input, and our L2 is always going to be the Y, which is going to be our output. So L1, I'm so sorry. So L1 is going to be your X and L2 is going to be your Y. So it says plot the points on a scatter diagram. So what I'm going to lead you through today are some of these directions on your sheet for this unit. These are your direction sheets, so why don't you grab that sheet. I believe yours is another color. I like to make them, I think it's blue this year. So this year take out your blue sheet. I want you to check out where it says to make a scatter plot, and that's a little bit lower here. To make a scatter plot right here. So take out your GDC, graphical display calculator, and I want you to press on. Okay, running through the steps, we first have to put our information in. So press stat and then edit. L1, as you can see, I already have the numbers in, are my X values, which is my screen area. L2 are my Y values, which is my price. So go ahead, pause the videos and put those in. All right, welcome back. So we're right here at this step right here, second Y equals. So we're going to push second Y equals, and where that's going to get you is to what's called stat plots. And stat plots are where you plot your data. Make sure that 2 and 3 and 4 could be off. If they're on, sometimes that messes up your data. So you make sure that those are off. Most likely they are. We're going to go to number 1. So we're going to press 1 or enter either one. And if your little black box, and I call it highlighting, if your on button isn't highlighted, please highlight your on button and then press enter. And that's what it says, highlight on and press enter. Down arrow to type, highlight first graph. So press your down arrow, here's the first graph that's highlighted. Enter, down arrow to X list. Enter, down arrow to X list. Second one, enter. So what that's doing is making sure your L1 is in there. Mine is in there. If you want to just make sure, you can press second one and that gets you L1. And then we're going to push enter again. And then second two. Second two, make sure that your X list is, your Y list is L2. So your X should be L1, Y should be L2. It doesn't matter what mark or what color you have. I'm just going to leave those as is. I am here now. I'm going to be needing to see my graph, so I'm going to press zoom and then I'm going to press 9. So zoom, when you press zoom, you see 9 here is zoom stat. That helps us to see our graph. So I'm going to press 9 and there we go. There's our graph. Notice there's no labels, there's no numbers. If you wanted to see a number, you can simply push trace and that will show you here is the point 154, 250. So if you want to add that, trace, you can push trace and that will help you to see your points. Now when you sketch this, let's just take out the sketch that I made here. When you sketch this, you can simply put the labels here, put the price, and then really plot the points as they look. You don't necessarily need a perfect graph here. A sketch is just the overall pattern of the points. So the reason why I gave you this nice drawing with the specified scale here is because we're actually going to be plotting some points. So sketching again, labels, title, and the overall pattern. Okay, so we're going to use my drawing, which has scales on it. So number 1 is done for us. Thank you very much. Number 2 is write an interpretation of the data. So to interpret my data here, I am going to be needing to take out, and I think it's right underneath here. I'm going to be needing to take out my notes on interpreting scatterplot. And what we're going to be doing is we're going to be writing about the form, whether it's a straight line, curved, or clusters, if there's any outliers, points that lie outside your data, the direction of the graph, whether it's positive or negative, strength, whether we have a strong linear or no linear, and making sure we use context, always mentioning what the scatter plot is about. And so I have actually written the interpretation here for you, and I'm going to review it with you as if I would be grading it. So this is what I'm looking in your write-up. So I will read it to you, and then we're going to go back to make sure those elements are in there. We're going to check them off as we see them. So let's do that. I chose to use a scatter plot to observe the relationship between my two quantitative variables, which are screen area in square inches and price in dollars. Screen area determines the price. Therefore, my independent variable screen size will be located on the x-axis, and my dependent variable price will be located on my y-axis. Once graphed, I observed a strong positive association between the screen area of a LCD television and the price. As the screen area increases, the price also increases. There are no apparent outliers, as there are no points that lie far outside the overall pattern. I also observe a linear pattern and will calculate the value of the Pearson's product moment correlation coefficient, known as R, to test the strength and verify the direction of this relationship. To three significant figures, the calculated value of the correlation coefficient is 0.979. Since the correlation coefficient is very close to +1, I can claim that there's a very strong positive linear relationship between screen size and price. Due to the strong correlation, I can now calculate the equation of the regression line and make predictions of price based on screen size. All claims can only be generalized for these data on the specific manufacturer's flat panel LCD televisions and price. So you can use this setup and you can input where your variables are and how you see your patterns developing. What do I mean by that? Let me read through this and tell you why I wrote each sentence, and also check off the elements that we need. This first sentence here tells me why I used a scatter plot. The reason I used a scatter plot is because I have quantitative variables. When I have two quantitative variables, I want to see the relationship in the best way as scatter plot. Then I told you where I actually am going to locate the screen area and the size. This second sentence lets you know my dependent variable is going to be on my x-axis, which is always true. My independent variable will always be on the x-axis, and my dependent variable will always be in my y. And this is true. So what I did is I inserted my variable. Screen area is independent, so on the x, and price is dependent, so on the y. Next, I'm going to tell you what I'm going to observe when I graphed. When I graphed, I observed a strong positive association. So here, strong, we have strength, so I'm going to mark S. Positive association, we have direction. So remember, I need form, outliers, direction, strength, and context. So far I have my strength and my direction. And I also have context here between the screen area and the price. Awesome. Okay. Next, as the screen area increases, the price also increases. This is increasing my knowledge of what's happening with my direction. So I'm explaining what a positive association is using my variables in the sentence. There are no apparent outliers, as there are no points that lie far outside the overall pattern. So here are outliers. So O for outliers. And I also, in this sentence, I told you why. So as there are no points that lie far outside. So that's why there are no outliers. I also observe a linear pattern and will calculate the value of the Pearson's product moment correlation coefficient, known as R, to test the strength and verify the direction of this relationship. So here we have my form. So I did all of my 5 elements here. And I also said, since there was a linear pattern, I can now find my correlation coefficient. And I said why. Because I need to just test the strength and verify the direction. So I'm always claiming and then backing it up with why I'm doing it. Backing up with what evidence I can provide. To three significant figures, the calculated value of the correlation coefficient is 0.979. So I just want to bring you back to these directions here. For your correlation coefficient, your R, you're going to use linear regression. This is going to help us to get our R. When you do that, you have to first make sure your stat diagnostic is turned on. Most likely, once you turn it on, it will be turned on. So let's take out our calculator out, and let's run through making sure our stat diagnostic is on. So I'm going to move this over because of there we go, the little screen. Okay, so first we press mode, which is right here. Scroll down to stat diagnostics, and that's right by your stat wizard. Some of you know your stat wizard. And you need to right arrow to highlight on, and then you press enter. Perfect, we turn our stat diagnostic on. Again, once it's on, it's usually on, and that will help us to get our R. Then we're going to press second mode, and it's going to quit. Okay, now let's find our R using these set of directions. So first we have stat 1. So we have to enter our data, X values in L1, Y values in L2. We just did that, so we're ready to rock and roll. Next we're going to press stat, and then we're going to right arrow over to calc. So this is where you're used to pressing one variable statistics. Please don't, because what we need now is to go down to 4. 4 is linear regression. And that's what we're going to be working with. So I'm going to press 4, and we see linear regression AX plus B. We're going to press second 1 because that's where my X values are, and my comma second 2. And then we're going to press enter. When you see this, some data comes up. We're going to be using A and B shortly. I'm going to let you know what R squared is. However, the last value, R, is right here. As we see, it's 0.9785468255. I'm going to go to three significant figures on this, and I would like you to always as well. So this is 0.9785. This 5 is higher, this 5 are higher, so I'm going to round that to 9, and that's how I calculate my R value. Okay, let's go back to reading and reviewing the sentences. Since the correlation coefficient is very close to 1, I can claim that there is a very strong positive linear relationship between screen size and price. So I verified my direction, I verified my strength, my direction, my form, and I used context using this correlation coefficient. Now you also have a nice typed up sheet that tells you if it's strong, perfect strong, positive strong, moderate, weak, no correlation. So here, this is +1 right here, +1, perfect positive. And it goes all the way down to -1, perfect negative. And I need you to notice that when it is very close to 0, that's when we're going to get no correlation. Very close to 0, no correlation, meaning we don't have a linear pattern. There may be another pattern, but we just know it's not linear. Okay, we can put this sheet aside. All right, and getting down to the end here, due to the strong correlation, I can now calculate the equation of the regression line and make predictions. So because this is strong, this is saying that this graph is now a nice linear pattern, and I'll be able to make some predictions based upon it. And the last one, this is my disclaimer. I love putting disclaimers in. You always hear me to say disclaimers in class. All claims can only be generalized for these data on this specific manufacturer's panel LCD televisions and price. So I'm saying the only predictions I'm going to be able to make are from this data. I cannot generalize outside of this data because I don't know what happens in anybody else's store. I don't know. But I know what happens in this store, and so I can make my claims based upon this data only. So be careful, because that's going to come into our validity when we write our IAs. So this is an amazing paragraph. Use this for your IAs, use this for your interpretations, read it over a bunch of times, maybe even like before getting on the bus. Okay, or going to bed. Just keep reading it over. Maybe just tape it to your wall. Okay, next, let's see what else we have to do. All right. Next is going to be finding the mean screen area and the mean price. And so if you take out your trusty sheet here, it's going to say to find means. And so to find the means, we're going to be, I just press second quit. That's what I'm doing every time to clear the screen, is second mode here, and that's quit. All right, we're going to have to stat edit, which we already have our data in. And again, we're finding means, so we're finding the mean of x and the mean of y. And it's going to be in a point form. Okay, so we're going to right arrow, so we're going to have to go back to stat, go to calc, and instead of pressing one variable, because we don't have one, we have two now, x and y, we have to go down to two variables. So be very careful when you're doing this. It's now two variable. You press enter, and like before, we want to tell the calculator where our data is. It's in L1 and L2, and we press enter. Now you see here, here's the x bar. That's the mean of that's the mean of x here. If you scroll down, you're going to see the mean of y. So it's going to give you both sets of data. That's why it's two variables. So let's scroll back up and let's write down our mean of x and our mean of y. So the mean screen area, which is our x bar, is 329. Oh, sorry. Backwards. Okay. 392.33. Now I'm just going to go to the second decimal place here. Let's do that. We're dealing with money, so we can, I know this is square inches here, but it would be nice just to go to 2 on both. And the mean of y in dollars was 407.5, and 2 decimal places because this is money, so it would be 50 cents. So we found the mean screen area and the mean price. Let's see what we do next. Plot this point on your scatter plot. Okay, so we're going to go back, and to the best of our ability, we're going to plot on our scatter plot. Move this over. Here we go. 392. So this is a point. So this point is 392.33 and 407.50. So we're going to go to 392, and then we're going to go over here. So this is about 392, very close. It's not going to be perfect. And then we're going to go up to about 407, which looks like about here. If you would like to take a ruler out and do it, then that's perfect. And I'm just going to label it M because that's going to be our mean. So there's our mean point because it looks like it was originally there. That's actually pretty nice. Okay, so we plotted that. Check. Use your graphical display calculator, GDC, to calculate the equation of your regression line. That's going to go back to here, linear regression. And I want you to notice these notes that I wrote down here for you. These notes tell you what your slope is, which is your A, and your y-intercept. I actually even say correlation is R, and then this guy right here is the coefficient and determination. We are just going to stick with what A and B are, and we are going to insert or substitute those numbers into this equation. So you're going to take your calculator, I just second mode again, and you're going to start from here because our data is already in. So stat, and we're going to scroll over to calc, press 4, and again tell the calculator where our data is. And you see we have an A and a B. And so what students really like to do is they like to write down what their A and B is. So A equals you can do 0.769. I'm going to go to 3 significant figures. B equals 105.737. You cannot leave it like that. I need an equation. An equation has a y, an equal sign, and an x in it. The number that goes next to x is going to be your slope, which is your a. So I'm doing y equals ax plus b. So y equals, my a is 0.769x plus b. This is positive, so I'm going to put a plus plus 105.737. If b was a negative, you would put minus. This right here is my equation of the regression line. This is my answer. Please give it to me in that form. Sorry, I'm very passionate about this because it's true. Please give it to me in that form. Thank you. Okay. Use your means and the y-intercept to sketch the regression line on your scatter plot. The y-intercept, everybody, is B. So your B is 105.737. That is your B. Now, in point form, the B is going to be 0 because it is the y-intercept, so x is 0. It's going to be 105.737. That's our y. So we're going to be plotting this point. This point is going to be on our y-axis as it is the y-intercept. So we're going to go over here. We're going to be plotting the point 0, 105.737. We're going to try our best to get to 105 because if you look at this graph, it starts at 200. So in reality, this point is at this corner right here. It's not going to be perfect because the graph starts at 200. So it looks like it really is in that corner, which is true. And so you plot that point. It is on the y-axis. This right here, everybody, is the y-axis. This is our x-axis. So I'm plotting the point on the y-axis. I'm making it even bigger here, okay? This is our B. And so when we sketch this line, we're going to connect our B and our M. And I'm going to let you know you're going to have to do this. This is now your best fit line that you have actually graphed before in algebra class. We call this the regression line. So instead of calling it a best fit line, the statistical term is the regression line. So this is the regression line graph. This is the line that best fits our data. There you go. Now you know. Okay, let's go back to the end. We're almost there. Sorry, this video is a little bit longer, but I went over the calculator steps. Last, use your equation to predict the price for a screen area of 550 square inches. So they want us to use our equation. So what I'm going to do is I'm going to go down y equals 0.769x plus 105.737. Okay. And now what I do is this is x. They're telling me x equals 550. So I'm going to substitute it in for my x. So I'm going to put 7.769 times 550 plus 105.737. And we can put that directly into our calculator. So really, it's just going to be second mode. 0.769 times 550 plus 105.737. And I get 528.687. Because y is the value in dollars, I'm going to put 528.6. I'm going to round up to 69 cents. So if we were to buy a screen area of 550 inches, the price will be $528.69. Let's just write that out in a complete sentence. The price for a screen area of 550 square inches is 528.69. And I just want you to notice this is a point, okay? So we have our nice little graph. This is the point 550 and 528.69. And so I want to go back to my graph and I want to just see where that fits. So I want to see if it's a good predictor. So if I look at this point here, 550 is my x, so I go over to 550, which is about here, and I'm going to go up to 528, which is my y. So I'm at 550, I'm going to go up to about 528. What do you think that's like right here? So this is where my predicted price would be. That's pretty good. Actually, probably, I should break out my ruler, huh? 550, so I'm going to go up, and 528. Yeah, so it's up right there. There we go. It's right here on my line. That's my predicted. I need to bring out my trusty old ruler. That's my predicted price, which is on my line, so it falls in my predicted area. So this line is going to help us to predict based upon these points that were given to us. So this has been a lot and I hope that you watch the video again if you need to review. This is great for your IA because it is the process that you're going to use. It has been interpretation of scatterplot, correlation, equation of a regression line. Hope it helped, and good luck. Thank you.